So this is the video lesson for section 2.2. All right, so just a friendly reminder, remember I don't cover these sections in class, so make sure you watch the videos. All right, so in section 2.1, we discussed substances. And we talked about how sometimes they're called pure substances because they are uniform throughout, the same throughout. Today, we're going to focus on mixtures. So a mixture is a material of variable composition. Variable means it's not the same throughout. And so it contains two or more substances. So in other words, if you can think of things that had to be mixed together, that would be an example of a mixture. So things like salad and sweet tea. In salad, what is it made of? Well, it has lettuce, it has croutons, salad dressing, it has vegetables in it. All those kinds of things are mixed together to make the mixture. So it's not the same throughout. I could get a forkful and I might have a crouton on there, I might not. It's different throughout. All right, another example would be sweet tea. Okay, what's mixed together to make sweet tea? Well, first you soak the tea packet in, and that makes all the color and flavor come out. And then, of course, you have water and you have sugar and that type of thing. All right, now an alloy is a special type of mixture that has metallic properties. So an example would be sterling silver. Sterling silver is actually made of silver and copper, okay, and they're mixed together, and then we call that sterling silver. All right, so the important thing about mixtures is it's more than one thing mixed together, and it has a variable composition. So let's talk about the two types of mixtures. So the first type is heterogeneous. All right, hetero means different. Okay, it's not the same. Think about, heterosexual, a male and a female. A heterosexual couple. They're two opposite sex. Okay? Heterogeneous is different. So they have different properties throughout the mixture. And so in a heterogeneous mixture, when you look at it, you can actually see the different parts. Okay? So an example would be like a chocolate chip cookie. I can see where I have chocolate chips and where I don't. Okay? I can look at it and I can visually see the different parts. Another example would be like vegetable soup. Okay, again, I can visually see where some places it's just the broth, the juice. There's carrots in some places, tomatoes in some places, noodles in some places. I can see the different parts. Okay, so heterogeneous is a mixture that has different parts that we can visually see. All right, the other one is homogeneous. Okay, so homo means same. All right, so a homogeneous mixture is a mixture that has a uniform composition. Now, that wording seems to contradict itself, or at least it does to me. It says it's a mixture, which remember, a mixture has a variable composition that has a uniform composition. Well, those are two opposite things. So we're saying it's variable, but it's uniform. So a better way to probably state this definition than the definition I got from your book is it's a mixture where it looks uniform throughout, like it appears to be uniform. It's not really uniform.
Ryan Van, could you please report to the parking lot to your car, please? Ryan Van, could you please report to the parking lot by your car, please?
Maybe I'll at least make one video without an interruption. All right, so it appears uniform throughout because the different parts are so small we can't see them. And a homogeneous mixture is also known as a solution. So an example would be like Coke. Okay, when you look at Coke, it just looks like one dark brown liquid. Like you can't see where there's sugar, where there's caffeine, where there's water. You can't see those different parts. They are so small and mixed so well together, it appears that it's uniform. It's not really uniform, it just appears that way. Okay, another example would be like Windex. When you look at Windex, you just see a blue liquid. I can't pick out like, oh, well, that's water right there. This part is the blue dye they add. This part is the base that they use for the cleaner. You can't visually see those different parts. They're there, but we can't see them. Okay, so heterogeneous, it's variable throughout in a way that we can notice, like the chocolate chip cookie. Homogeneous, it is variable because it is a mixture, but it appears to be uniform. So maybe even write that in your notes packet. Just add under uniform appears, because it's not really uniform, it just looks like it is. Like Windex, it looks like it's all the same thing, but really it's a bunch of things that have been mixed together. All right, so let's move on and talk about how to separate mixtures, because some sometimes we get a mixture, but we want it to be pure. Like for example, this is why we have billions of dollars probably spent on bottled water, because we want pure water, and what comes out of the faucet, as we discussed already, is not pure. Okay, so let's talk about some ways that we can separate mixtures. One of the ways is through filtration. So for example, you've seen on TV like a Brita filter. They'll hook it to the faucet, the water passes through it, and it's supposed to remove some of those impurities. Okay, so filtration is a method for separating the components of a mixture containing a solid in a liquid. Okay, so in other words, it can remove solids from a liquid. So, for example, the most common filtration that a lot of people see in their houses is a coffee filter. Okay, you put the grounds, the solid coffee grounds, into the filter, and then hot water passes through. Well, the water can go through that paper filter. The solid grounds cannot. So what happens is the water goes through, and as it's passing through the grounds, it absorbs the flavor, the aroma, the color of the grounds, but then it's just the liquid that passes through. The grounds stay stuck in that filter because the solid can't pass through the paper. We do the same thing in lab all the time. Okay, so they poured something into, this would have a little filter right in the bottom, and if you notice, you have a big chunky solid right there at the top, and in the bottom all you have is a liquid. Okay, now in class, I will show you a real example of filtration, of course, but watching it in a video doesn't really make any difference, so I'll show you that in class. So let's look at another way to separate. Another way of separating is distillation. That's another way that we purify our water. You can buy distilled water at the store. Okay, so distillation is a method for separating the components of a mixture based on the different boiling points of the components. So for distillation, you can separate a solid and a liquid, or you can actually separate two liquids. Okay, and filtration can't do that. If I had two liquids mixed together, filtration cannot separate them because they would both pass through the filter paper. But because distillation is based on boiling points, it could separate two liquids. So let's talk about it real quick. Let's say I have one liquid, let's say we have water. It boils at 100 degrees Celsius. Let's say I had something mixed in with water that boiled at 200 degrees Celsius. Well, when I start heating my mixture, who would boil first? Well, the one with the lower boiling point, the water. So once it hit 100, the water is going to boil and come through here and condense again, but the thing that boils at 200 would not. So as long as we don't heat it to 200, that would separate it. Okay, and again, I will show you a real example of distillation in class because again, showing it on a video just isn't as good as seeing it in real life. Okay, so filtration separates a solid from a liquid using filter paper. So the large particles stay in the paper, the smaller particles will pass through. And then distillation separates based on the boiling points of the substances. All right, so let's move on to section assessment. So how are mixtures classified? Well, we talked about two types, and they were heterogeneous and homogeneous. All right, heterogeneous and homogeneous. Remember, heterogeneous, you can see the different parts like a chocolate chip cookie. Homogeneous, you cannot, like Windex. All right, so number 2, it says classify each of the following as a homogeneous or heterogeneous mixture. So again, y'all, when you think about these, I just want you to think, can I see the different parts, or does it look like one thing? Okay, so food coloring. Do we see different parts of food coloring, or does it just look like a colored liquid? It just looks like a colored liquid. We can't see the different parts, so that would be homogeneous. All right, ice cubes in liquid water. Now, I know you probably think, well, that's just all water, which it is, so that was a good thought. All right, but when we're talking about mixtures, we still consider the different states of matter to be different parts. So can you see the difference in the liquid and the solid? Yes. So since we can visually see those different parts, this would be considered heterogeneous. All right, next one is mouthwash. So again, do you see stuff floating around in the mouthwash? Well, I would hope not. Okay, there's nothing in the mouthwash. It just looks like a colored liquid, so that would be considered homogeneous. If you have stuff floating in it, you know, you must be drinking out of the bottle and backwashing a little bit. Probably need to throw it away, get a new bottle, start over. All right, next one is mashed, unpeeled potatoes. So what would that be? Well, if they didn't even peel them, I'm going to be able to see the little pieces of peel in there. You know, like how those red skin potatoes, sometimes they don't peel them at restaurants. So I'm going to be able to see those different parts. I'm going to see, you know, the white potato, and I'm going to see those little pieces of peel. So that would be heterogeneous. All right, so number 3, how are a substance and a solution similar? So if you remember from section 2.1, a substance is uniform throughout. A solution, remember, is another word for homogeneous mixture. And what did we say about those? They look the same throughout. It's not really, but it appears the same throughout. So that would be how they're similar, is they both look the same throughout. Okay, so they both look, I'm going to put that in quotations so you remember that solution's not really the same throughout. They both look uniform or the same throughout. How are they different? That's a good question to follow up on this, because how are they different? A substance really is uniform. A solution just appears to be. Okay, so a substance really is uniform, but a solution just appears to be. Okay, so remember, a substance really is uniform. It's the same throughout. A solution just looks like it is. Remember, the Windex really is a mixture of different things. It just looks like one liquid throughout. All right, so let's look at our last couple on the next slide. So it says, in general, when would you use filtration to separate a mixture? Okay, well remember, filtration holds what in the filter? The solid, and lets what pass through? The liquid. So you would use filtration when you want to separate a solid from a liquid. Okay, ooh, I didn't give myself a lot of room to write. I'll just put it up here. So filtration we use to separate a solid from a liquid. All right, the important thing to remember about filtration is it separates based on particle size. Large particles can't pass through the paper, smaller ones can. All right, and then it says, when would you use distillation to separate a mixture? Well, remember, you could separate a solid and a liquid using distillation, or you could separate two liquids using distillation. But the important thing to remember, to use distillation, you need to have different boiling points. If you had two liquids where the boiling point was almost the same, then you wouldn't be able to separate them. Okay, so for distillation, we'll say two substances with different boiling points. So again, for distillation, it could be a solid and a liquid, it could be multiple liquids. All right, but as long as you have that difference in boiling point, you can separate them. All right, and then last one, number 5, describe a procedure that could be used to separate a mixture of sand and table salt. Okay, so we have two solids mixed together, sand and table salt. So what could we do first? Well, the first thing I would do, so I'll just put step 1, is I would add water. Because what would water do if I added it to sand and table salt? Is it going to dissolve the sand? No. Is it going to dissolve the salt? Yes. Okay, so I would add water to dissolve the salt, which is NaCl. Hopefully you already knew that. Water, H2O. Hopefully you already knew that. All right, so now I have salt water and sand. So which process would I want to use first for salt water and sand? Well, the sand is a solid that does not dissolve. Okay, it's just going to stay as a solid. So if I pour it through the filter paper would collect the sand. Okay, so my second step, I would say filter out the sand. Because again, if I pour it through, the salt water will pass through the paper, but the sand would be caught in the paper. Okay, so now I'm going to be left with salt water. So how can I separate that? Okay, well then what I could use is distillation. A lot of times students tell me you could evaporate the water. Of course, that's also an option, but I'm trying to use our techniques that we just learned. Okay, so then you could distill to separate the water and salt. Now, one thing that I want to point out real quick is a lot of people think, well, salt is a solid, so wouldn't salt get caught in the filter paper when you pass it through? Well, salt is a solid, but the thing is, when you dissolve a solid into a liquid, the particles become small enough to pass through the paper with the liquid. Okay, so filtration cannot separate a dissolved solid. It would just have to be a solid sitting at the bottom, like sand sitting at the bottom of water could be filtered. If something has been dissolved, it will not filter out. And so in that case, your only option for a dissolved solid is distillation. And a dissolved solid is actually a distillation that I'll have set up for y'all in class that I'll show you. All right, so that is section 2. Remember, mixtures, variable throughout, homogeneous, heterogeneous, and the way we separate them is filtration and distillation.